Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, me and my teammate will answer a question about conservation of momentum. And this question is about collision. So, the question is, in a rugby match, a 90 kg forward in one team tackle on a 80 kg backline in the other team. So, the forward travelling from left to the right and the backline travel to the left at 7 meter per second in the opposite direction when they collide and they stick together. So we can see here this question is about collision because they collide and stick together. The velocity of the forward when he is jogging is 2 meter per second before he start running toward the opponent. So the acceleration for the forward is 1.5 meter per second when he start running, and he takes 2 seconds to reach to the opponent. So as you can see here, this boy is a forward while this is the back line. So the forward from the left to the right, he start running, and the back line from the left to the right. So this boy have a mass of 90 kg, while this boy have a mass 80 kg. The velocity of this boy when he run towards the backline, we does not know because it does not given in the question. But the velocity of this boy from the right to the left is 7 meter per second. So the first thing first is we need to find is the velocity of the boy when he start running, because this velocity is when he jogging. So we need to find the velocity when he start running towards the opponent. So we use a formula is, so the first thing first is we need to do is to find the velocity of the forward player when he running to the opponent, because the velocity given for the forward is when he jogging. As we know, rugby does not always stick to the one point. They always running around the field. So the first is we need to find the velocity when he running toward the opponent. So we use a formula V0 plus acceleration time equal to V1. The V1 is the velocity for the forward player when he running toward the opponent before they collide. So V0 is 2, the velocity of the forward when he jogging, plus acceleration is already given 1.5 times 2 seconds. He takes 2 seconds to reach to the opponent or to the backline, equal to V1. So we get V1 is equal to 5 meter per second. Okay, after we get the velocity when the forward start running towards the opponent, we can answer the question. This question is we need to calculate the velocity after the collision. So the first thing first is we need to do is to draw FBD before collision and after collision. So this represent the forward player. It move from the left to the right with a mass 90 kg, and the velocity when he running towards the backline is 5 meter per second. So this is present the backline player with mass of 80 kg, and it move from the right to the left, and the velocity is negative 7 meter per second. Why we put the negative? Because we take the direction of the forward as the positive direction. So this we draw after collision. So after we draw, it will make our calculation, or we mind is more easy to see what happened. So as you can see here, this is after collision. So after that we use a formula. M1 equal M1 V1 plus M2 U2 is equal to M1 plus M2 times V. So this is the formula before collision, and this is after collision. So the M1 is the mass of the rugby player of the forward, and this U1 is the velocity of the forward player from the right to the left, and M2 is 80 kg, the mass of the backline player, and U2 is -7. Don't forget to put the negative because it will affect our answer. So after that we solve the calculation, and we get the V is equal to -0.65. So the answer is shown that after the collision, the collision is like move to the left because the backline player has more momentum than the forward player. So we answer the question 0.65 meter per second left because the collision it move to the left. They collide and they move to the left because the backline player has a larger momentum than the forward player.
Okay, for this question show need to be show the calculation whether this collision is elastic or inelastic. So this question said this collision need to be proved this collision is elastic or inelastic. Okay, let me show you the formula that we need to use to solve this question. Okay, E RF plus E RB equal 1/2 M1 U1 square plus 1/2 M2 U2 square. Okay, E refer to kinetic energy, F for forward and B for backline. So M refer to mass, U refer to velocity at forward 1, mass refer to for particle backline mass. Okay, U velocity, U is velocity for particle backline. Okay, we go to continue our calculation. Okay, M1 is 90 kilo. Okay, the velocity for U1 is 5 milli per second. Okay, plus 1/2 80 kilogram for mass of the backline. Okay, 7 for velocity of the backline. Okay, square. Okay. Then this is the answer for this formula, and this formula before the collision. Okay, we need to compare it the after collision. Okay, is mass for forward and mass 2 for backline. Okay, V2 we get from previous question. Okay, why we need to prove this collision is elastic or inelastic. So the answer for both question has a large difference between the value. So it show the collision is inelastic because if elastic, they will bounce and have a same amount of joules, amount of kinetic energy, or slightly same. This is as a large kinetic energy, so they have they stick together, and this shows the inelastic collision. Okay, that's
For
all.
my question is, how much energy was lost in the collision? So for this question, we must find the kinetic loss energy. For before collision is 3085 joule, and after collision is equal to 35.9125 joule. This answer get from the previous question that we find the kinetic energy. So to find the total loss energy is total loss energy equal to before collision minus after collision. For before is 3085 joule minus 35.9125 joule equal to 3049.09 joule. From this answer, we know that in this inelastic collision, which there is a loss of kinetic energy while the momentum of the system is conserved in inelastic collision. Kinetic energy is not. This is because this energy, some kinetic energy, has been transferred to something else, like thermal energy and sound energy or other else.